It is a project, Canny edge detection algorithm for color images. Through the project, we'll build an edge detection algorithm which can sketch the edges of objects on color images. Let's first try to answer the question, what are images? An image is a rectangular array of pixels for color images. Each pixel has three values, RGB, red, green, and blue. In the RGB representation, an image can be considered as a function defined on an image domain omega. For example, this is an image domain, and the image function has three components, and each component is non-negative, so it can be considered as a three-dimensional function. In reality, the image domain is an array of integers, and it is saved on integer valued array. That's called the sampling. And image values also are integers between 0 and 255. That is called the quantization. When the camera is acquiring the light signal, the signal is separated into RGB components. Each component is a continuous signal. Now, for effectiveness, the continuous signal will be partitioned into integer values, and from 0 to 255, so that the signal can be saved much more effectively into a smaller space, and also we can deal with the integer values conveniently. If we look at the image as an array, then it is in M and D. Here M is the number of rows, and N is number of columns, and D is dimension. D is either 1 or 3. If it is 3, then it is the color image, and now if D is 1, then it is a grayscale image. The color images can be transformed to a grayscale image quite easily by using the formula. This is most frequently used formula, and also in MathTalent, if you are using RGB to gray, then this formula is used. RGB, three values are averaged along with that weights, so that the gray value is a weighted average of RGB. Okay, this is about images. Most of edge detection algorithms are developed for grayscale images. Of course, you can apply edge detection algorithms for color images. However, you should first transform the color image to a grayscale one, and then you can apply the edge detection algorithm. Edge detection algorithms consist of a few steps. For example, the Canny edge detection algorithm has 5 steps. The algorithm was published by Canny in 1986. Here are the 5 steps: noise reduction, gradient calculation, edge thinning, double threshold, edge tracking by hysteresis. We'll learn Canny's algorithm implementing every step in detail. Here, let's see a a program using a built-in function called edge. But let's see the main part. This part is setting up parameters, and then here we choose the image saved in the directory data. Lena image is selected. After reading it, we change it into an array of double precision values. So here, the image values will be scaled so that the values will be between 0 and 1 rather than from 0 to 255 integer values. But yet it is a color because each pixel has 30 values, only scaled. And by using RGB to gray, now we have grayscale image. Okay, after calling this one, now we call the built-in edge detection algorithm by using the grayscale image, and method is chosen here, Canny method. Okay, now we save that. Here we see the result. This is the Lena image in color and grayscale, and that's the result of the function edge. Here Lena donated her picture to the image processing society, and the image was used, having been used for various image processing tasks. So overall, she contributed a lot to the society. So we should appreciate her donation and contribution. Okay, the edge is not perfect. For example, around there is no edge. However, it has some edge components. It's not really perfect. However, it is acceptable. Okay. So by choosing some parameters more reasonably, you can ignore this portion. But anyway, and there are many places where it's not really perfect. For example, also this portion possibly must be ignored, but here you can see that portion. Okay, here there is a critical issue on edge detection algorithms when color images are transformed to grayscale. It is occasionally the case that edges either lose their strength or even disappear. Let's see this colorful image, and once it is transformed to grayscale, then you have this one. And except these two blocks, every else, various colors are transformed into almost the same gray value, so that you see very flat grayscale image except these two blocks. So if you apply the function edge, then you'll get only these two blocks. So this is a toy example. However, if you try to get edge detection for color images, then you have to be careful when you try to transform it to a grayscale. So here in our project, we'll do this here, project objectives. The project will develop an edge detection algorithm, which is less problem, so more effective for color images. We will design an effective algorithm as good as or better than the well-tuned built-in function edge. for your convenience and success, you will be provided with a model code saved in this file. From the lecture note, if you click this portion, then you can download the packaging. Let's see here, model code. Okay, in the program, and last moment we added here new trial. Okay, there is a function named edgeDetection.m, and we call and color edge along with the color image, and that is for text processing. The name of the images now used in this program. Now here the color image, that is a new trial. Okay, here now there is color image. Let's see again the major parts. Okay, and here this is step 1 and step 2. And step 1 is image denoising or noise reduction or image blur. And you can use the built-in function Gauss filtering algorithm. Now, rather than that, we may try to use TV denoising. We'll see the details later on. Now, in step 2, here now component wisely, channel by channel, and for each channel case from 1 to 3, now the denoised and saved into U, and now for each channel we try to get the gradient magnitude by using the Sobel gradient, and saved into grad and component wisely. And now for each one, this is edge direction estimated, so theta is made. So we finish step 1 and 2 channel by channel, and then before going to step 3, we have to make the gradient intensity in 1D. Here we try to choose maximum out of the channel by channel gradient, and that is saved here. That index, which is used to select the angle from the component-wise angle. Okay, so that now angle is saved into TH, array TH, and by using the 1D gradient intensity and corresponding angle, we try to do edge thinning using the method non-maximum suppression. So we'll see details of this algorithm also. And in fourth step, here we'll do double threshold, and here for this step you have to set these two parameters, high ratio and low ratio, appropriately, and then call this double threshold. Then you will get the pixels indicator for strong edge and weak edge, and remain the pixels are not relevant, so that you can select strong and weak pixels for edges out of that. Also, this function is implemented in the packaging. Here, the fifth step, which is the last step of the Canny edge detection algorithm, and you'll do this one by implementing a function for hysteresis, and also I'll give you information in detail. And now we'll consider another step, extra step in step 6, and that is edge trim. You'll see why we need that. Okay. Okay, that's the rough scope of the project and model code, and we'll consider details from part 2. Thank you.